everyone, my name is Miss Kay. Welcome to today's lesson. Before we get started, before I introduce what the lesson is, I want you to take a pause and really think about what you notice between all of these pictures that you see here. If you're with someone else, you can do a quick think, pair, share and share your ideas. However, I want you to hold that thought as we move through the lesson. So pause the video if you need more time to think about it. So today's lesson, we are talking about linear relationships. So what is the relationship between two values that increase at a constant rate or a steady rate? I have the expectation below. That's more so for my teacher. By the end of this lesson, you'll be able to represent whatever information I give you in a word problem with concrete materials, with a table of values, with a graph, and with an equation. You will also be able to describe and identify the rate of change and initial values in each representation. You're also going to be able to make connections between the four types of representations that I just told you about. Let's get started. When I say rate of change, this means calculating the slope. The slope of the line is right here, and the slope of the line is always our rise over our run. So how much are we increasing in the y value over the increase in the x value? So as you can see here, the slope of this line, we are increasing by 2 and going over by 3. So our slope, as you can see down here, also represented in green, is 2 over 3. Our next key term is our initial value. Our initial value here is where are we starting on this graph? Where does our line run into that y-axis? So what is our y-intercept? Here, we can see that it's a 1. And down here, in our equation of a line, we can see that it's also a 1, and that's represented by our b. This is confusing to you. Don't worry. This is what we're going through today in our lesson. Our example here is you are now running a lemonade stand and we are looking at how much it costs altogether. It costs you $3 to buy all the materials that you need for your lemonade stand, and then it costs you $2 to make each jug of lemonade that you will sell. So we're not looking at how much you make. We're looking at how much it's going to actually cost for you to produce this. So our startup cost, like we said, it's $3. So your tablecloth, your cups, whatever, $3. From every jug that you sell, it's $2. If you don't sell any, your cost is $3. If you sell one, your cost is now $5. If you sell two, your cost is $7, $9, $11. We see that it's increasing by $2 each time. Our two questions here are, what do you notice about the blocks that are increasing? Well, they're increasing by 2 each time. We can see that going from 3, 5, 7, 9, 11. It's increasing by 2. What's staying the same each time? $3. We will always have that $3 there no matter what. Whether we sell 0 or we sell 1 or 2, we're always going to have that. That's our initial value, okay? So whatever's in green, that's called our rate of change. It's changing by a +2. How does this look if we were to put this information into a table of values? We have our x and our y. Remember, we are looking at how is the y increasing? Well, let's put it in. So when we've sold 0 jugs of lemonade, our cost is $3. If we sell 1 jug of lemonade, our cost is $5. 7, 9, 11. What is the rate of change? Like I said before, the rate of change is just what are we increasing by each time? As we can see from this table of values, while our jugs of lemonade is increasing by 1, our cost is actually increasing by 2. So that's why I've drawn a little arrow here with the 2. We're going up by 2, up by 2, up by 2, up by 2. Our rate of change is 2. What is the initial value? The initial value is what we started with. When we haven't sold any jugs of lemonade yet, what is our cost? Well, looking at this table of values, our cost is 3. It's the same up here. Whatever you see in this representation, we can take that data and put it into the table of values. It's going to be the same. The initial value here, when x equals 0, our cost, or our y, is equal to 3, which means our cost, before we've even sold anything, is $3. And let's graph this information. We know that our jugs of lemonade are x, and we know that our cost is our y. Let's put them together. Let's make coordinates as I've done here. So our 0, 3, 1, 5, 2, 7, 3, 9, 4, 11. Let's graph that. 0, 3, 1, 5, 2, 7, 3, 9, 4, 11. Let's add our line of best fit. Go straight through those. How would you describe this line? I've shown pictures here of a positive slope and a negative slope. Think about it. Positive, I'm going up the hill, and negative, ooh, I'm sliding right down. This line is going up, shooting towards the sky. This line has a positive slope. And as you can see here, we're going up by 2, over by 1. So we know that our slope is 2. Where does the line start? I honestly think it might be easier to see this from the graph because it's wherever it intercepts this y-axis. So when x equals 0 here, what is our y value? Our y value is 3 right here. We can see this here. When x equals 0, y equals 3. What does that tell us? It tells us our initial cost when we haven't sold any lemonade yet. Okay, so our starting value is $3. It's going to cost us $3 to even start before we sold anything. Our last form is in an equation. We've done a concrete example, we've done a table of values, we've done a graph, and now it's equation of a line. So how can we take that value and put it into an equation? Every time you write an equation of a linear relationship, it's y equals mx plus b. I don't want you to get nervous. We're going to explain what these variables mean. Our y and our x are going to stay as those values. The only things that we're going to plug into this equation at this point in time is our m value and our b value. Now, throughout this presentation, I've been color coding things, okay? Our m is whatever was green throughout the presentation. That's our slope of our line. And our b is whatever our initial value was, so our y-intercept, okay, when x equals 0. In this case, our m is 2. So we went up by 2 and over by 1, up by 2 and over by 1. And our initial value is 3. Whenever x equals 0, y equals 3, I'm just going to plug that into my equation. And there we go. My equation of a line is y equals 2x plus 3. As you can see, I still have my y, I still have my x. Okay, I'm just changing and substituting my m and my b value. My m is my slope, my b is my y-intercept or my initial value. Let's move on and let's look at the relationship between all of the different representations that we've shown. So our concrete example here, our table of values, our graph, and our equation of a line. I want you to think, how can I pull this information looking at all 4 of these graphs? Because they all represent the same thing. But how can we see that? How do we know that just by looking at it, that they all represent the same thing? What's the rate of change in each? And how do I pull it out? What's the initial value in each? And how do I pull it out? I want you to pause this video. I want you to think about it. For each, I want you to talk about what's the rate of change? What's the initial value? And how did you know that? How did you pick it out? Take a few seconds, pause the video, and then we'll talk about it on the next slide. So looking at this, everything that's pink is my initial value. So looking up at the front one, like we said, we started with 3 coins. In our table of values, when x equals 0, our y equals 3. At our graph, when x equals 0, our y equals 3, right here in pink. And in our equation, it's whatever our b value is here at the end. Now, what's our rate of change? What is it increasing by? I've represented this in green here. So each time up here, we're increasing by 2. We're adding another 2, 2, 2. Here, we're going up by 2. So 3, 5, 7, 9, 11. We're going up by 2. Down here, we're going up by 2, over by 1, so our rate of change is 2. And then in our equation, it's whatever our m value is, and that is our 2. Before the end of this lesson, I want you to challenge yourself and think about, if I asked you, what is the cost, or the overall cost of making 5 jugs of lemonade? Which one would you choose to represent that? And I want you to go ahead and do that. So are you extending your table of values? Are you extending your line on your graph? Are you writing a new equation, or are you plugging values into your equation, which is a little bit more challenging? Or are you going to use your pictures above and add in your coins and just extend that relationship? So I would love for you to move forward and do that. And if you have any questions, you can totally check in with a partner or come and ask me, and we can go through it together. So thank you for joining this lesson, and I hope you enjoyed it.